Okay, so here's the section 3-4 on reading unit circle and coterminal angles. Let us, before we dive into this section, go over a couple of the trig functions that you have become acquainted again with from sections 3.1 to 3.3. So we have come across the review of geometry where sine theta will end up being the length of your opposite side over your hypotenuse side. The cosine of theta is going to be the adjacent over the hypotenuse. The tangent of theta will always be the opposite over the adjacent. You were then also introduced to the reciprocal trig functions. The reciprocal of sine is the cosecant of any angle. So that just required you to take the ratio that you have of sine and flip it. Numerator becomes denominator and the denominator becomes the numerator. The other two, secant theta and cotangent theta, you do the same thing. Take the reciprocal of cosine, the h over a, and cotangent, it's going to be a over o. Now, what I want to show you guys is when you were using these ratios and evaluating the trig functions, you were specifically working the entire time using images of a right triangle, okay? So how are we going to use these trig functions when looking at a unit circle, okay? So if you recall the construction of the unit circle, we did a lot of embedded triangle drawing to show you how certain coordinates came about on the unit circle. So let's revisit a second here, the right triangle. Okay. And let's take, for instance, that this right triangle is in the unit circle. So this will be the center of that unit circle. And this is one of the points sitting on the circumference of that circle. And we're going to label it, oh my, that's really bad handwriting. We're going to label it x comma y. Right? Why? Because if I calculate the distance here, I had to move a certain x distance. And then if I had to calculate this distance, I moved a certain y distance. So that's why it's at x comma y. Now we know that this is the radius of the unit circle. And as such, the radius is equal to 1. Okay, so that is a length of 1. And this right here will be our angle theta. Okay, so what I want you to understand is when I tell you, when using the unit circle, that sine theta is equal to y, I want you to understand why that's the case. We know that sine means, opposite over hypotenuse, correct? Well, if we look at this picture and we're standing at theta, the opposite side is going to be this side. The adjacent side is going to be, I can't spell, is going to be this side. And the hypotenuse is going to be this side. Okay, again, because you're standing here at theta and you're looking across for opposite, at the side for adjacent, and then across from the 90-degree angle, you guys always know, is our hypotenuse. So looking at evaluating cosine theta using that triangle, the cosine theta would be adjacent over hypotenuse. Well, our adjacent is x, and our hypotenuse 1, so x over 1 is just going to be an x. Our tangent opposite over adjacent would be y over x. Now, when asked to find cosecant, secant, and cotangent, well, we know that those are the reciprocals of sine, cosine, and tangent. So the cosecant of theta is going to be whatever that y value is, but take the reciprocal. The same thing with cosine. Secant is going to be the reciprocal of cosine. And then the tangent, which is actually cotangent, it will be the reciprocal. So we're looking at x divided by y. So I want you to keep these definitions handy as we jump into practicing some of those problems, okay? These definitions are what you will use, okay? These definitions right here are what you are going to use primarily when evaluating functions using the unit circle, okay? So let's proceed. Here's the unit circle, and before we do these problems, I want to remind you guys what we were doing from before. If you guys remember, when we were constructing this unit circle, we would, which we just did too, okay? We drew triangles on this unit circle, and we were figuring out what the distances were for x and y right here and right here using our special right triangle ratios, and that's how we figured out what this coordinate was right here, okay? And we did that several times, okay? So picking another color here, we then did this triangle right here, okay? So what I want you guys to understand is every single time we did this, and if you keep wrapping yourself around this unit circle, it's continuously going to keep going all around. I can't seem to get it to, well, you guys know what I'm trying to do. Trying to make it to look like a 90 degree, but it just won't do it. All right, so it's a really bad 90 degree. It's not letting me. I'm gonna try it one more time because it bothers me. It doesn't want me to let it go, but you know what I'm saying. So if we keep doing this over and over and over again, you're going to see many triangles embedded, okay? So you are still doing right triangle trigonometry, but this unit circle is like a quick reference guide so that you do not need to be continuously drawing all these triangles. All right, so how are we going to use this? Reminder that this is an x value, this is a y value. All of these are the coordinate points of how to get to those points from the center of our circle, okay? So it took me a certain distance x, 1/2. It took me a certain distance y, square root of 3/2 to get to this point, okay? Now, here's what you're going to do. Let's go on to work out some of these problems. So, when I ask you to evaluate or find the exact value of the trig function, for instance, tangent theta, okay, what is theta in this problem? Well, our theta is 60 degrees. So we're going to rewrite this as tangent of 60 degrees. But tangent means y over x, okay? So remember that that's what I told you a couple of pages back. And so we are going to need the y coordinate and the x coordinate at 60 degrees to be able to do this problem, okay? So let's go to 60 degrees. So 60 degrees is right here, okay? And so we are going to use the x and y of this. So the y was square root of 3/2 and the x was 1/2. So y was square root of 3/2 divided by x, which is 1/2. Now, because our denominator values are identical, we can cancel, And we're left with square root of 3. I'll write it over here. Square root of 3 over 1, which just simplifies to square root of 3. Okay? So let's try it again for sine of theta, where theta is now 225. So let us do it. I ran out of space. Let's go here. Sine of 225 degrees. Well, what is sine of 225? That means they want us to find the y distance of that triangle. If we had to draw a triangle of 225, look at it right here. Okay, they're asking us to find that y distance. Well, that y distance is the y of the point over here on this side over here. So let's go to sine of 225. Here's 225. And so we are looking at these points. Sine means find the y, and the y here was square root of 2 over 2, but negative. So the answer to this is negative square root of 2 over 2. So I want you to pause the video here and do number 3, 4, and then 5, 6, 7, 8 on your worksheet. Okay, so you are back finding out the answers for 3, 4, 5, 6, 7, and 8. Sine theta, well, this is what you should have done. So let's pick another color here. Let's do this one. So sine, our theta is 90 degrees. Sine, we know, is our y variable. So if you go to 90 degrees, here's my 90 degrees. My y is a 1. Cosine theta for number 4, we rewrite it as cosine of 150. Cosine of 150 is asking us to find the x at 150 degrees. So let's go back. Where's 150 degrees? It's right here. So we're looking at this, but we are focusing on our x. Negative square root of 3 over 2. So negative square root of 3 over 2. Let's go to number 5. Now we're being asked to find cosine of 90. So I'm going to put these answers in because I think you guys are getting the gist of it. Whoops, I went back too far. Cosine of 90. So here's cosine of 90. Well, there's the 90 I mean. Cosine means the x. That's my x. So cosine of 90 is 0. Tangent of 240. Tangent of 240 degrees. Okay, so let's find the 240 degrees. Let's change a color. Let's go to blue. Tangent of 240. So here's my 240. So I'm using this right here. So tangent tells us to take our y values and divide it by our x values. So negative square root of 3 over 2 divided by negative 1/2. So negative, remind myself, y divided by x. So negative square root of 3 over 2 divided by negative 1/2. Recall that I told you guys your denominators are identical, so you are able to cancel. So you're left with negative square root of 3 divided by negative 1. The negatives become positive, and square root of 3 divided by negative 1, negative is going to be positive square root of 3. Let's try number 7. Let's see. Cosine of 135 degrees means go find the x at that angle. 135 is right here. So my x is negative square root of 2 over 2. Let's do the tangent of 150 degrees, which is y divided by x. So let's go to the unit circle and look at the tangent. Oh goodness, what was it? Of 150. Forgot about it for a second. So the tangent of 150 degrees is in the second quadrant of the unit circle. And so we are using these points. By the way, I don't think I've gone over quadrants recently. To remind you, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? You read it counterclockwise. Okay, so back again. We're doing tangent of 150 degrees. So it's going to be 1/2 divided by negative square root of 3 over 2. So 1/2 divided by the negative of square root of 3 over 2. But just like we've done all along, the 2 and the 2 are both denominator values, so we can easily just go and write what stayed in the numerator, just a 1, what stayed in the denominator, a negative square root of 3. Now, if you recall, I've told you guys that I do not want any square roots in the denominator of fractions. So that requires us to have to rationalize. So let's rationalize in this problem. That means I have to multiply top and bottom by square root of 3. So 1 times square root of 3 is just going to be square root of 3. Square root of 3 times square root of 3, or negative square root of 3 times square root of 3, well, that's just going to be negative square root of 9, which is just negative square root of 3 over 3. Most of you guys don't even do this step here. I was just showing you why it ends up being just 3. The remaining problems that you see in this section are now going to be dealing with angles that rotate in a different section and some radians. We were doing all in degrees, so let's try it with radians. So cotangent of 7 pi over 4. So let's look at our unit circle for where 7 pi over 4 is. So 7 pi over 4 is right here, 4th quadrant. Okay, 4th quadrant. Now, what does that mean? They're telling us to find, what was it? Cotangent of 7 pi over 4. So we actually are going to need both of them because it's a cotangent problem. Okay, so cotangent of 7 pi over 4 is still going to be equals to, instead of y over x, it's going to be x over y. So what is our x? For 7 pi over 4, it was square root of 2 over 2. Over the x is square root of 2 over 2. I forgot this one was, wait, one of them was negative, right? Yes, the y value. Yep, it's in the 4th quadrant. Okay. So, as you take the cotangent of 7 pi over 4, what are we getting? Well, these two numbers are identical. Okay. So if they're identical, we can easily just say that they're canceling, right? And the answer would just be -1. All of the angles at the 45, I'm going to circle them here. If you take tangent or cotangent there will be 1 or negative 1. So for instance, let's do tangent. If it's tangent, then I'm asking, that's y over x. These two, if you divide them, 1. If you divide y over x here, it's going to be negative 1. Down here, it's going to be positive 1. Down here, it's going to be negative 1. Okay? Because these two segments right here, they're either both positive or both negative, so they cancel out to be positive 1s. Here, these two, one sign is positive and one sign is negative, so the answer has to always be negative. Oh boy, I didn't want to erase the whole thing. All right, let's just erase it with the eraser before. All right, and I lost my train of thought of what we were doing. So if you can bear with me as I erase here. Got sidetracked. There's so much information to be given in the unit circle section. Okay, I hope I didn't need that line. I think that was from a previous problem. Okay, what? There we go. Where was I? We were doing cosecant of 2 pi over 3. So 2 pi over 3 is right here. Cosecant is related to sine, and sine is our y. So cosecant will be related to y as well. So square root of 3 over 2, cosecant literally means find the reciprocal of sine. Okay, that's literally what it means, okay? So what was the y value in this problem? Well, the y value for 2 pi over 3, we said was square root of 3 over 2. So we're going to have to flip it and make it 2 over square root of 3. But if you rationalize, then you need to multiply top and bottom by square root of 3 to get rid of that radical in the denominator. So our answer will be 2 square root of 3 over 3. Okay, so bear with me here with tangent of negative 13 pi over 6 and cosine of negative 17 pi over 3. Okay, so I need to go to tangent negative 13 pi over 6. I'm going to erase this here. You know what? Let's make a bigger eraser. There we go. Why isn't it erasing? There we go. So we needed to do tangent of, I have such short-term memory, negative 13 pi over 6. So I'm going to write it over here so I can't forget it. Okay. So I want you guys to notice something right here, okay? If I asked you guys to count, I'm going to make some really thick lines here to make it a point. If I asked you to find how many 1/6 there are in this 1 unit circle, okay? I'd hope that you would notice that almost the end is 11 pi over 6, so that when you get here, it's going to become 12 pi over 6, okay? So let me show you using a little bit of color to make you understand that, okay? So if I start at the 0, okay, wow. Let's see if this is going to work. Why is it so out of range? I don't think it likes me doing it so thick. Let's make it a little bit smaller. Maybe it'll help. Okay. If we start at 0 and we go to pi over 6, that's 1. But I have to keep counting in that size. So let's count. That was 1. That was 2. That was 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the last space is 12, okay? So I want you to realize that there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of the pi over 6, okay? So there are 12 pi over 6 sections, all right? Which makes sense because 12 pi over 6 is 2 pi, and 2 pi is 180 degrees. Now, erasing all this beautiful stuff, let's talk about pi over 4. How many of those do we have? Okay, well, again, we have our 0. We start, then we go to pi over 4. Now I need my pizza slices, so to speak, to be that large, okay? So that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then the last one is 8. Again, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pi over 4. So why don't you pause the video and tell me how many pi over 3s do we have? Tell me how many pi over 3s do you have? All right, so let's do that. Pi over 3 is right here. So the size of our slices should be about that big. So that's 1 pi over 3. That would be 2 slices of 2 pi over 3. Here's going to be the third one. Here's the fourth one. Here's the fifth one. And to make it all the way around, you need to get to 6. Visually, 1, 2, 3, 4, 5, and 6. Okay, so we have 6 pi over 3. Again, 12 over 6 is 2, 8 over 6 is 2, 6 over 3 is 2. So those are all different ways of being able to deal with this. So if I ask you to find a very big number, remember those increments, and it's easy to count by. So we were doing tangent of 13 pi over 6, but negative, okay? So 13 pi over 6 is going to pass 1 revolution, because we already established right up here that there was only 12 pi over 6 in 1 revolution. So what you're telling me is for 13 pi over 6, you went 12, but you had to go a little bit more to get to 13 pi over 6. So the coterminal of 13 pi over 6 is going to be pi over 6. But the catcher is, they told us that it was going to be negative. Negative means you've got to go clockwise. Okay? So rotate in a downwards fashion. Okay, so let's focus on the fact that we just want to know where tangent of 13 pi over 6 is. So 13 pi over 6 means we had to count a whole bunch of 6s. We know that we wrapped around and we got to 12, but we needed to go a little bit more to get to 13, okay? So if you look at this, this was 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, all the way to 11, 12, 6. But I need to go to 17. Was it 17? Look at me in my short memory. 13. So from here, from 12, I needed to go a little bit further. And I stopped. Because 1 full rotation was 12. And then this right here, 12, 6 plus another 1, 6. That would make 13 pi over 6. So what I'm trying to get you to understand is finding the tangent of 13 pi over 6 will be the same thing as finding the tangent of pi over 6. Okay? So, I know I need to do y over x, but I also know that I was supposed to count in the opposite direction. So what I mean by that, since it was negative, I needed to count this way get to 12 pi over 6 and then go a little bit further to get negative 13 pi over 6. But what I tell students is this: if you just are more comfortable doing positive, do positive tangent of 13 pi over 6. So let's do it together. We start here, rotate till we get to 12, and then we need to go a little bit more to get to 13. So right there. And that little bit more is the 1/6. Okay? So what's the coterminal angle? I accidentally stopped recording. What is the coterminal angle of tangent of negative 13 pi over 6? Well, side note, if I'm doing positive 13 pi over 6, I know it's going to be, what did we say? 1 pi over 6. Okay? But I'm asking for negative. So here's what I want you to realize. If I'm saying that pi over 6, okay, is my answer for that, that's positive, but I need the negative answer. So I need to go downwards across the x-axis. You'll always go across when you are looking for the negative angles. Okay, so find the positive angle. Remember, we did loop it around for 12 and went a little bit further more for 13. Here was the red dot was what we found for positive 13 pi over 6, but we needed negative, so we need to jump across the x-axis. So this is the angle that we're going to use. So the tangent of negative 13 pi over 6 is the same thing as, I forgot to write tangent. It's the same thing as tangent, I'm going to write it over here actually, the tangent of what? 11 pi over 6. And we know tangent means y over x. So my y was negative 1/2 and my x square root of 3 over 2. I went in the wrong direction. So negative 1/2 and square root of 3 over 2. So here, our 2's are going to cancel out. And so we're left with negative 1 over square root of 3, which we know that we need to rationalize. So negative square root of 3 over 3. All right. One more for section part 1. It's a long lesson. I'm so sorry. Cosine of negative 17 pi over 3. Let's go back over here and let's do 17 pi over 3. So let me erase this. Okay, and we are doing, let's write it over here, cosine of 17 pi over 3. All right, so we already established that one full rotation was 6 pi over 3. And we need 17. We actually need negative 17, but you remember I told you, let's focus just on the on the positive, and we'll come back and see about that negative after, okay? So, if there's 6 pi over 3, we have to go all the way to 17. So that means I'm going to rotate, and I'm going to get to 6 pi over 3. But I need to go all the way to 17. That means I still have to go another 11. So that means I'm going to go another 6 at least, because that's 6. And if I go another 6, I'm going to reach to 12. So right here, I'm sitting at 12 pi over 3. So from 12 pi over 3 to 17 pi over 3, if I have to go from 12 all the way to 17 pi over 3, how many more do I need to go? Well, I need to go 5 more, right? So I'm going to change color here just to make a point. So I'm going to keep going, and I'm going to keep counting. There's my 1/3. That's another, there's 2/3. See, I'm marking right there. I'm going to keep going. 3/3, 4/3, 5/3. And I'm going to stop right there. See, there's my 5/3. So 12 thirds plus the 5 thirds, which is the red, gets me to 17 thirds. That is the answer if it was a positive 17 pi over 3. But since it's negative, I need to go take this dot and I need to go all the way up, jump over the x-axis, and use this one. And my arrow completely blocks off what the number is, okay? So pi over 3 is what I need to write over here. So the cosine of negative 17 pi over 3 is cosine pi over 3. So these angles are coterminal angles, okay? This angle and this angle, they're coterminal. That's what that means. All right, so cosine pi over 3. Cosine means you are looking for an x value. Go back to pi over 3. Pi over 3 x value is 1/2. All right, almost there, you guys. Okay, last but not least, this is part 2 of your assignment. Now, of your notes, I mean. So inverse trig functions. Inverse trig functions basically is us going to find angles, okay? You are now finding angle measures. And you will either give your angle measures in degrees or in radians, okay? So there are a couple of conditions that need to be met in order for you to begin looking for the angles given certain characteristics. I need you to recognize that when you are looking for the inverse sine of an angle, okay? Now, speaking of inverse sine, I want to clarify some notation before I go further. The inverse sine notation can be one of these. Either it's written like that, sine inverse with the looks like a -1 power, but it's not a -1 power. You read it as sine inverse, or you will see it written like this. And I want you to know that both of them mean the same thing, okay? They both mean the same thing. So this one here will be either cosine inverse, or you read it as arc cosine. Same thing, okay? They both mean the same. And the last one, tan inverse, or you will see it written as arc tan. They both mean the same thing. Okay, so let us talk about the conditions, okay? So right here, they're giving us certain conditions as to where these angles are located, and I wanted to show you better pictorially what that means. So what they're asking you to do is, if you're looking to find the inverse, the sine inverse of a given ratio, that you will only find the answers in these two quadrants, in quadrant 1 and in quadrant 4. But there's something you've got to recognize when you do it. If your answer is in quadrant 1, your angle is read this way, okay? And that angle has to be between 0, I'm going to use degrees, and 90 degrees. But if your angle is caught in quadrant 4, I need you to read it this way, okay? This way. Notice my arrow. So that means that angle is going to go from 0 degrees all the way to -90 degrees, okay? So your numbers, your angles are going to be lower than 90 or -90 and greater than or equal to 0. When it comes to inverse cosine, your inverse cosine angles will always be in the first and the second quadrant, okay? First and second. And in these quadrants, your angles are always going to go from 0 all the way to 180 degrees. And then when it comes to inverse tangent, it is the same as the one above with inverse sine. Your angles will either go from 0 to positive 90 or from 0 to negative 90. Okay, so 0 degrees to positive 90 degrees or 0 degrees to negative 90 degrees. And of course, that applies to radians too. Okay, so 0 to pi over 2 or 0 to negative pi over 2, 0 to pi, and you know the unit conversions. Okay, so remember, you are completely ignoring, I'm going to use white just to prove a point. You are completely ignoring this side. That doesn't even exist. You're not even concerned about that side of the unit circle. You're not concerned about this side. Okay? You're not concerned about this side. So literally just ignore it. So that really makes things a lot simpler when you're looking at the unit circle. You're like, okay, well, I just need to focus on these two quadrants to find my answer. Okay? So let me just put those back there and let's go to the next page. So here's our unit circle and we are going to do a couple of these problems. Okay? So let's start off with this one right here. Sine inverse of square root of 2 over 2. So we're looking for an angle. And remember, anytime you see an inverse, you're just looking for an angle. So they want us to give the answers in both radians and degrees. So I'm going to say the theta. How am I going to write this? Let's write it this way. Let me just write this. The sine inverse of square root of 2 over 2. That's going to be, I guess I could put theta equals, okay, because that means an angle. Sine inverse of square root of 2 over 2. What does that mean? What does that notation mean? Okay, well, that notation merely means the following. You have to know what sine means in the first place, and I think we've practiced enough that you know sine means y. So that notation basically says, I need you to go find the y, or find the angle. Sorry, let's go find the angle, because theta means angle, where the y is negative square root of 2 over 2. Okay, but let's establish where sine is. Sine inverse, I mean. Sine inverse we established was going to be here in the first quadrant or here in the last quadrant. Do you remember that? So let me see if I use a little highlighting here, if that makes sense. I knew that my answers had to be in these two quadrants. But I'm looking to find where in these two quadrants is the y value negative square root of 2 over 2. Well, between these two quadrants, my y values are only going to be negative in the bottom quadrant. And I find it right here. Y is negative right there. Okay, so what angle is that? That angle was 11 pi over 6. But remember, we are reading the angle this way. Okay, oh, wait a minute, it's not negative square root of 2 over 2. Oh my goodness, pause a second. Alrighty, I am so tired and I'm making a lot of mistakes. Let's erase this here because I was looking at the wrong one. Okay, I will still keep this highlighted, but it was sine of square root of 2 over 2. So sine inverse of positive square root of 2 over 2. So sorry. So let's try that again. So where is the angle going to give us a y of square root of 2 over 2? So our y is positive, and y is only positive in this upper quadrant, and here is that y value. So what is that angle? That angle is 1 pi over 4 or 45 degrees. So pi over 4 or 45 degrees. Let's try this again. Let's try now cosine. Let me pick a different color here. Let's try cosine inverse of a half. So let's do theta equals, because theta means I'm looking for an angle. the cosine inverse of 1 over 2. Again, what does that notation mean? It means I need to go find an angle where x is a half. Why am I saying x? Because we established that cosine is our x distance, our horizontal distance. So let's go back to our shading, okay? Where is cosine located? Well, cosine is located at the top quadrants, right? That's where it's located. So we know that our answers have to be somewhere in this area, okay? Where is cosine or x a positive a half? So if we look, we find that the x is positive half here in the first quadrant, and we look to find the angles that are assigned in both radians and degrees, and it's pi over 3 or 60 degrees. Let's try another one. Tangent inverse of 1. So let me write it in a different color here. Theta equals tan inverse of 1. So where is it that y over x, if you divide the y and the x, where will it end up being a 1? So tan inverse, where is that located? Do you remember where to shade? All right, tangent is shaded on this side. So where is it going to give us a positive 1? Where, when we divide y and x, do we get a 1? Well, take a look at this, okay? If I try to do 1 divided by 0, that's undefined. You can't divide by 0. I can't, if I divide this by this, I'm going to get square root of 3. But look here, if I divide this by this, I am going to get 1, okay? Over here, I do get sort of a 1, but it's going to be negative 1 down there. So I don't want to do these right here at all because all these are positive and negatives, and I need a positive 1. So I know it has to be in this first quadrant. But this is the answer right here. Square root of 2 over 2 divided by square root of 2 over 2 is going to give me a 1. So my answers are going to be 45 degrees or pi over 4. Okay, so that's this one right here. Alrighty, let's go do another 3. We did the first 3 already. We're now on this one, sine inverse of 0. So theta is what we're looking for, the angle measure, sine inverse of 0. Of 0. Sine inverse, where is it located? Sine is located here and here. So where is sine inverse 0? Well, sine means where is the y equals to 0. So if you look at all where I shaded, that's not a 0, that's not a 0, that's not a 0. Yay, there's my 0. Okay, so what angle is that? It is angle 0 degrees or 0 radians. Okay. Alrighty, let's do the next one. The next one is cosine inverse of 1. Let's do it orange. Okay, so theta equals the cosine inverse of -1. So cosine is what? What variable is cosine? Well, where is x going to be? -1. Cosine means x. Where is cosine to be shaded? Where are our answers? They are only located up here on the top two. And so again, walk around and look at your x's. And as you make your way around, you'll notice that x equals -1 is way over here on the pi equals 180 degrees. Okay? So hopefully this is coming across a little bit easier for you. Sine inverse of -1. So theta equals sine inverse of -1. All right, let me do some erasing here. Give me a second. Sine inverse, again, tells us to focus on this side. And where is sine inverse going to be -1? Sine means y. Where is y -1? Where? Okay, that's the question. What angle? What angle is giving us a y of -1? Well, there's our y of -1. And what was the angle? There's the angle. 270 degrees, or 3 pi over 2. And let's see, I think I have one more paper. Yes, I do. Hang in there, we're almost there. Let's use pink. Second to last one. Theta. Don't like that. Let's try that again. Theta equals the tan inverse of -√3 over 3. Okay? So what angle is y over x going to give us -√3 over 3? Okay? Well, first we have to decide what two quadrants we're using. Where's our tangent? Well, our tangent is located here. So we ignore completely the other two sides, okay? So look at this. We're looking for an angle that has -√3 over 3 as our y over x. So what's awesome about using the number √3 is that you can start eliminating stuff that are definitely not going to work. For instance, this number right here doesn't even have a √3 in our setup, so it's never going to be an answer. This one might be. This one doesn't even have a √3. Might be. Doesn't have anything. Might be. Doesn't have anything. Maybe. Doesn't have anything. So right now, if you look at this, the only ones that possibly can be answers are this one, this one, this one, or this one. But can we eliminate it even more? We absolutely can, because notice your answer is negative. So that means right off the bat, we can eliminate this one and this one because they're both positive. So we're only left with 50-50 chance, okay? The 50-50 chance is this one right here and this one right here, okay? Pretty easy. So let me erase all this mess so that you can see the problem better, okay? So hopefully you have seen that we established that the only answers possibly that can work are these two. So which one is it going to be? We needed to be able to divide y and x to get -√3 over 3. Well, hold on, I'm going to make some space to write. So I'm going to make this area over here really white so I can write in it. Okay, because I'm running out of space. So if I needed to divide y over x for this problem, that's going to be -1/2 over √3 over 2. Well, I'm going to cancel out the 2's. And so now I'm left with, I forgot what color I used, -1 over √3. But we need to rationalize. So I'm going to multiply √3 top and bottom. That gave me -√3 over 3. So that actually works. Okay, that one worked for this one. So check mark on that. It worked on the first try. our answer is going to be 11 pi over 6 or 330 degrees. Okay? If you're not sure why the other one didn't work, I can do it really quickly right here. If we did y over x on this one, it would have been negative square root of 3 over 2 over 1/2. Well, notice that when you cancel out the 2's, you're left with negative square root of 3 over 1, which is negative square root of 3. We wanted negative square root of 3 over 3, okay? That's not the same thing as negative square root of 3. So that's why this one ended up not working. So 330 11 pi over 6 was our answer for that one. All right, one last one for the road. The last one was the cosine inverse. Theta equals the cosine inverse, or arc cosine, of negative square root of 3 over 2. So where is the angle? Find the angle where x is negative square root of 3 over 2. Well, let's erase all this mess here. Where is our cosine inverse answers? Well, where are? Speak correct English. The cosine angles, the inverse cosine angles, are located upstairs, right here somewhere. So where is our x? Negative square root of 3 over 2. So checking x's. Oh, wait, they said negative. X's are negative on this side. So checking, voila. There are our answers. So 5 pi over 6 or 150 degrees is our answer for inverse of cosine of negative square root of 3 over 2. All right, my dears, very long lesson. Hopefully that helps you if you're listening to it all over again or if you missed class. As usual, reach out if you have any questions. Thanks for watching.